Another utility function that we have available is the IDCAMS. And the AMS on the end of this utility stands for Access Method Services. And it is typically associated with processing VSAM files, but it is also used to manage catalog entries, define other VSAM structures, and to define different elements that would be associated with the system catalog. So in general, the IDCAMS function is going to be used to define VSAM structures. We can define non-VSAM catalog entries. We can use it to copy data between files. We can import and export VSAM files, which creates portable copies that can be moved between systems. We can alter existing definitions for these VSAM files. We can connect and disconnect catalogs. All of these things represent the various functions that IDCAMS is capable of performing. And the JCL requirements are basically to have the sysprint that allows for a message data set, and then any name that we choose for the DD name. And this is going to be identified on a control statement. And in addition, then, we would have our sysin statement, which identifies the control statements that are going to be input into IDCAMS. Here's an example of the basic JCL, and you'll notice that we have a DD name here that is variable that will be specified on the control statement, and we can indicate our input or output files that we are using here. Now the control statements here are a little bit more sophisticated, which means that we can conceivably even eliminate the role of the DD statement by dynamically allocating data sets and specifying the data set name within the control statements themselves. An example of the non-VSAM control statements involve things like defining non-VSAM, which adds an entry into the catalog. We can define the generation data groups, as we saw in the earlier module. We can do a list cat, indicating that we want to list the catalog entry at a particular high-level qualifier level. And we can list specific entries from the catalog. These are all examples of non-VSAM usage of the IDCAMS utility. We can also delete entries from the catalog, and in this particular case, when we remove an entry, that means that any attempt to locate that data set again will result in it not being found in a catalog search. However, it does not delete the data set itself. The data set still resides on whatever volume it was defined on, and as a result, if you know the volume serial number, you can still access and retrieve the data using a volume serial number specification. Here's an example of some control statements where we are defining a non-VSAM data set. In this case, you can see we specify the name, we specify the device type of a 3390, and then we identify the volume serial number, that is the volume where this data set resides. In the second example, this is another example just as we used before with the generation data groups, where we've identified the base name, a limit of 5, and then the scratch and the no empty parameters indicating how we want those generation data sets to be treated. In the case of a non-VSAM file, when we list the catalog, in this case we are listing the level, you'll notice that we have these non-VSAM entries that indicate the data set names, and then of course the volume serial number and the device types, just as we had seen earlier. For VSAM control statements, we do have specific files, and we can use these to define various VSAM structures. We can delete various VSAM datasets, and we can use the list catalog to list detail information about the VSAM datasets themselves. In this particular case, you can see that we have much more extensive control statements involved in creating these particular VSAM files. And since we are not digressing into a discussion of VSAM itself, the main objective here is to just understand that there are a wide range of control statements that can be used to create VSAM files. The information that is displayed in the catalog for the VSAM entries includes a lot of data statistics, whether it be record counts, record activity, the amount of free space, the amount of update activity, as well as data characteristics and other information that would be pertinent to managing those particular types of files. The general control statements for IDCAMS involve things like modifying an existing definition, importing a data set which is a portable copy from another system, exporting a data set to create a portable copy, verify, which basically confirms a logical end of file within a data set and ensures that it is properly closed, a repro, which basically performs an IEB gener type of sequential copy. So these are the types of entries that we have. You'll notice that we also have the print mechanism that we can use then in order to print the contents of a particular data set. So IDCAMS performs a lot of activities that are replicated from other utility programs, and this allows us to operate against VSAM files as well as non-VSAM files for these type of functions. Here's an example of printing a VSAM file. In this particular case here, we are printing a sequential file, and we are printing it in hexadecimal. And so as a result, all of the data is coming out to us in hexadecimal. Although we can specify that we want it to be printed in character form, and what we're getting here then is we're getting the detailed breakdown then of the individual records that are being presented to us.